Automata box constraints. You want to go ahead and open the Automata assembly. So in your Automata shared parts, you find the assembly and you open it. You don't have to create a new assembly. You can open the one I've already created for you. You should not get the message I did. I was showing things in first period, so there's a message there. Once you have the Automata assembly open, we are going to place a few of the components. So back in this folder, we are going to place the axle bushing, and we can bring in 2 of those. And we're going to place the crank, 1 of those. So all 3 parts are placed. I didn't even worry about rotating them like we have before because our constraints are going to make this really easy. We want to take this part and put it in this hole. The easiest way to do that is under the constraint box, there's a fantastic thing called insert. This part inserts into another part, and it's really easy. The only thing you need to know with insert, if you look very, very closely, is you need to know 2 lines that would be touching each other. When you insert, it's not like mating a center line where once you figure it out it's in the center, the part can still move back and forth on that center line. Insert actually takes that away. So you got to know what is touching. So in this case, if I want to insert, this is the outside of my box. I have to select a line. So I'm selecting under insert this outside kind of edge here, and I get a center line right away. But I'm selecting an edge this time instead of a surface. Then I go back to this and I say what edge kind of touches that one, and that's going to be this inside edge here. So if I click that, I can zoom back out and you can see that it is now properly constrained. The larger diameter piece is on the outside of the box, the smaller diameter piece goes to the inside. I apply. If I get out of my box, the only thing that it should do is rotate. It's done. 1 constraint to have that work. Do the same thing on the other side very quickly. Doesn't even matter what order you go in. Apply. Fantastic. Now what we have to do is constrain these so they rotate together. To constrain them so they rotate together, I want 2 of the surfaces inside to actually be lined up. So there's actually a couple different ways to do that. One way is when you constrain, you can do an undirected angle. So you can select angle and undirected, and you can just select one inside surface of the bushing and another inside. And it'll rotate them, it'll make them 0 degrees. Another way to do it, and I think this will work, is a flush constraint. So now those 2 surfaces, even though they're apart and away from each other, they're flushed on the same plane. So the whole idea is figure out which one you want, use it, and then when you turn it, it should rotate together. For some of them, you can't use the flush constraint because they're different sizes. This square here is the same dimensions of this square over here. That's why it works. If they weren't and you wanted the faces just to be turned the same way, you'd have to use an angle constraint. All right. Next, I'm going to take my crank and I'm going to put it on the outside of the box here. Again, this one is really easy. This crank was designed, if I go into the sketch of it, if we look, it was designed with 2 circles and tangent lines. There's a center point here of the circle that's on the end. Well, the box right here, this sketch, the center point rectangle is the same center as this outside circle. What that does for us is it allows us to use the insert constraint again. So I can select insert, I can select this outside of the bushing, and I find the center line there, and I can go to the back side of the crank and get the same center right through my square. So you can see there it's pretty equal all the way around. You know you did it correctly when you see that. I can apply that, hit cancel. Now the only thing is the crank just rotates, but not the bushings. So we need to set, again, a correct size of this. And to do that, these squares in the axle bushing and the square in the crank should be the same size. So I should be able to use flush. As long as it actually solves the solution and gives us a preview, it should be good to go. Boom. Fantastic. Next, one of the easiest parts to make is the axle that goes all the way through. So that's what we're going to do next. Once you find this length with the measure tool by selecting here and here, you can now use that dimension to create your axle. So we're going to go File, New, Standard.ipt. We're going to create a new sketch, and it doesn't necessarily matter which plane you put it on, but there's always a more correct plane. Back in my Automata, I want my axle to go from the right side to the left side. That would be the YZ plane. So if I select the YZ plane, rectangle, I can now draw it out. We are using 1/4 inch wooden dowels. So that's going to be a 1/4 inch by a 1/4 inch. Finish the sketch, extrude. I'm going to do a symmetric extrusion, and that is going to be 5.625 total length. Half of 5.625 extruded both ways. I hit OK, and I have my axle. I'm going to go ahead and save that in my folder. I already had it from another demo. You won't have it like I did. So save it in there. We've got the axle. We can go back to the assembly now. We can go back to Assemble, Place, find the axle, hit Open, drop it in there. We want this to find itself in the center here. Yeah, somewhere about right there. At least close to it. So to do this, we are going to actually mate the center axis that we created from the origin panel when we drew out our square to the center of this piece. If I click on the axle, it shows up in the browser bar. I can click this little arrow, and then I got the origin folder, click that origin folder. Because we drew this on the YZ plane, the x-axis is what runs directly down the center of it. So I can go back to Constraint, and I'm not going to do an insert. I can't do an insert on this one. But I'm going to select that x-axis. It grabs it, and I want this to be centered in this square. Well, this square doesn't have a center, but we know any circular piece on here shares that same center. So I can just find a circular piece, center it, click, and now it's centered on that center line. I'm going to apply that. And then I've got a few more dimensions. So one, it moves left and right, and when I turn this crank, it should move, but it's not. This is one of those times when you cannot use the flush constraint. The flush constraint cannot be used because this axle bushing, if I open it, and I use the inspect tool, is 0.26. And the whole reason for that is because this is a 3D printed piece, and I wanted to account for the plastic shrinking a little bit or expanding. So the axle is 0.25, and this will give me a nice fit in there. It actually is not too loose. When you go to put yours together, you might have to run your axle through it a few times, so it's not so hard to get on. It's almost like an interference fit when it's 0.01 larger. So to do this one, I can't do flush. I actually have to do the undirected angle. Select the middle, undirected angle. Select any surface in here and any square surface here. They're now 0 degrees. Apply. Let's just check to make sure. Awesome. Everything moves. The last part is to set it up. Somewhere right there. So that's just an easy flush constraint. End surface there. Apply. And if you look closely, you can see the difference in size. That's actually the gap going around it. At that point, you now have your assembled box. It's ready to go. Next steps will be done by your teacher.